Hi, welcome everyone. Thank you for coming. So in this talk, I will be first speaking about some existing declarative clients integrations that we've had in Spring Cloud, and then I'm going to talk and show the brand new Spring Interface HTTP client. My name is Olga Maciaszek-Sharma. I'm a software engineer with the Spring Cloud team. I mostly work on Spring Cloud Load Balancer, but I'm also the maintainer of Spring Cloud OpenFeign, Spring Cloud Netflix, Spring Cloud Square, and I've also been doing work on Spring Cloud Contract and RSocket HTTP Bridge. By the way, if any of you has never used RSocket, please give it a try. Fantastic protocol. OK, so what is a declarative client? Let's say we have two services that need to communicate over HTTP. We have some customer service that is going to register customers, but before it does, it wants to verify whether the customer is OK, because maybe the customer is some kind of fraud. And of course, we are dividing the responsibilities, so some other service is responsible for that. We are going to be sending HTTP posts at verify, and then we will be getting some kind of response with a customer verification result. There are obviously many ways to achieve this communication. So first, not the best, is just in whichever class we have that is responsible for the business logic, we inject a REST template or any other client, we set it up, add any custom headers, set up the URI, do whatever we are doing with it within this class, and then we call the client and we receive some kind of response. This obviously is not a very clean solution. So, as we are probably communicating with this client about maybe also using other methods, and we might be communicating with some other applications also than this verification client, we would prefer to have a cleaner solution. So we are going to extract it into an interface, create a method. Now we have set parameters, set return types. It is starting to look better. Then, obviously, if we are going to use it, we need to implement it. The good part here is that we can have various implementations. So we can also be using, let's say, web client or any other client. It doesn't have to be one implementation. And depending on the situation, on the environment, on whatever is happening, we can be modifying this. And then we can do all the preliminary setup in this implementation class so it doesn't leak into our business logic. And of course, we can. This is just a sample scenario, but we could, if we are really having heavy communication with a different application, we might be having a lot of custom setup that we need to do. So we can extract it into some kind of helper methods, and it is becoming cleaner. And then, of course, we call it in our business logic class in a very similar way. We just have this call to the verify method. And what if we could just only create that interface and add some annotations that we already use and know on the server side, and have the framework or the library underneath translated into the actual HTTP client requests? Let's imagine we provide the interface, we annotate it with the elements that we are expecting. We will see this in a demo in a moment. And then the library or framework has a proxy factory that creates a proxy that underneath translates the interface calls that we are doing into actual HTTP calls. So various of you might have already used similar solutions. One of them is Feign. And as you can see, that's what you provide, just an interface with some annotations. In this case, we have request line to specify the method and the URI, and then we can pass some parameters. Feign has been very popular. It's a Java to HTTP client binder. And previously, it was part of the Spring Cloud Netflix module, and then the core part was passed over to the community, and Spring Cloud started just providing integration. And Feign supports various HTTP clients under the hood, including Apache HTTP, Apache HC5, OK HTTP. It has this good concept of contracts, which allows to support custom annotations and resolve arguments in a custom way, which is what Spring Cloud OpenFeign is doing, and what we will see in a second. And it also has a broad range of encoders and decoders, including Jackson and JSON. Also, it provides support for micrometers and metrics. So, in Spring Cloud, we have this Spring Cloud OpenFeign project that provides integration for it. And what it does with the Feign project, it just makes it very usable with Spring Boot applications. And it allows you to take, instead of these Feign annotations, like we've seen, request line, param, and so on, use the annotations that are generally used on server side for the Spring controllers. For example, request param and request header, and so on. And then we are also providing a host of auto-configuration for Feign-specific beans, so you just add one starter, you don't need to do anything much. And then underneath, we provide, under the hood, the support for Spring Cloud Load Balancer and Spring Cloud Circuit Breaker, and also tracing through Sleuth. And from Spring 6, Sleuth will not be anymore available. It will be moving over to Spring Observability, and everything will be set up by Spring, Spring Boot, and separate projects. So we will continue supporting this. And this is what a Feign interface client looks like. So we are using the Spring MVC annotations this time, such as post mapping and request body and request header. And then whenever we call this method, we can pass the body object and we can pass whatever header we want. And the Feign client annotation on top with the verification service, this is the service ID. This will, what it will do, it will provide load balancing for us, so we don't need to know the host. It will just communicate, for example, with a discovery service, find all the instances of a service with the ID verification service, choose one depending on the algorithm we are using, and direct the call. So, of course, this is the way we are calling it, very similar as our interface. This time we can also pass the header or whatever else we have added in the parameters. And we can see it on the demo in a moment. As you will see, we will be communicating with Eureka using load balancer underneath, using Sleuth for tracing, and doing the communication between the two services. And what is most interesting for it is that the user has to do very, very little to achieve this. So let's go to our client. Yeah, this is our OpenFeign client. And we just create the interface, annotate it with whatever we need. And then we are going to add a bunch of starters. So we have the OpenFeign starter, the load balancer, Sleuth, and Eureka client. And I will show you where we are calling it. This is the method. So if you later see the demo, you can go through the various implementations we've seen that are commented out here. And yeah, pretty much everything else will be done for us. So we have this running in 9081, and we have the verification service running, where I will just show you where it is communicating. So we have some kind of controller. And as you can see, it's practically copy-paste because we are using the Spring MVC annotation. So it's the same kind of method. You just copy the declaration and the annotations on the client side. It will work pretty much out of the box. And we can run a post, and it works. So this is doing a lot of things underneath without the user having to do much. And what I wanted to show you also is that we are going to have the tracing information added for these calls. Yeah, so going back to the presentation, this project is very popular. It has around 800 GitHub stars, but what is more important, it has very big number of Maven downloads. Here you have the number just for 2021. And it is popular, we think, because it has a nearly flat learning curve for any Spring MVC users, because you can just copy-paste the annotations. But over time, we have had issues with this project. First of all, request mapping annotation in a controller, we would be able to use it at class level. But if we are going to use it in the client or interface level, it is causing many issues, and it has caused even a CVE. It has been something that we have been discouraging people from doing in the docs, but still, since this annotation was supported, a lot of users tried using it in this way, and it was not good. Then, also, since it is an integration for a third-party project, a lot of times we have situations when we had maintenance issues because in order to fix something, we were depending on changes in a third-party project, and we had to wait for that. And most importantly, I'd say this is the reason we are doing the changes that we are doing now, is it did not provide the non-blocking support. And without the core Feign project being re-architectured, we would not be able to provide it. So we have started doing some work on some alternatives to provide non-blocking support. There is a project called Spring Cloud Square, which has now version 0.4.1 available and released. And there we were providing support for retrofit interclients. So retrofit is very similar to Feign in the way it works. And we were providing all the support, so auto-configuration, load balancing, tracing, all the things that we provided for OpenFeign. The change that we introduced was that we only here supported retrofit annotations, not anymore Spring MVC annotations, to avoid these problems that we've had, for example, with the request mapping. And this was an incubator project. We had some users. We had some issues that we were fixing. We had some PRs. Some people started using it. And also, another project that was created by Josh Long was RSocket, which was a similar interface client, but this time for RSocket. And we also had this as the incubator project. Let me show you Spring Cloud Square for just a second. So again, this is just very similar. We have some loan service application where we can post at apply to try to create a loan. And this will be using a client underneath. And this is a retrofit client with Spring Cloud integration. So as you see here, we are using the retrofit annotations. So post and not post mapping, headers and not request headers, body, not request body, and then we have the retrofit client annotation. This is the one provided by us, and this will do all the auto configuration and also be responsible for the load balancing. And again, if we add the starters for load balancer, for Spring Cloud Square retrofit web client, and for OK HTTP, we will actually get all the integration done for us pretty much under the hood without us having to do anything. So yeah, the applications communicate, as you see, not much done. But going back to this, we had these two projects. So, OK, now even three, because we have the OpenFeign, which is super popular, but does not provide the non-blocking support. We have Square, which is just in the incubator, still has various issues, still not that much adoption, but provides blocking support, because another thing that we have provided there is to use web client under the hood. And unlike in Feign, where a lot of re-architecting would be necessary, with retrofit, it was very easy to just swap the client underneath. And then we have RSocket, which is just a budding new socket for RSocket interface. So we wanted to choose some way to go. And then we were starting to have this discussion with the broader Spring team about how we should approach this, because we had a lot of user demand, users were interested in this, but we didn't have a cohesive story. So we started thinking about taking these projects, so OpenFeign, Spring Cloud OpenFeign, Spring Cloud Square, and RSocket, merging them into one GitHub repository and creating one project under Spring Cloud called something like interface clients or declarative clients or whatever. But when we brought this idea to our broader team, we started thinking of whether we could, instead of providing a lot of integrations for third-party projects, maybe instead we could just start working on our own first-class solution in Spring Framework. So that would be easier for us in the sense that we would not have to depend on third-party projects for any maintenance. And also, if you look at it, the previous integrations that we had was just certain Spring Cloud components being added on top of external third-party projects. But we could provide the same integrations on top of something that we built ourselves in Spring Framework. So we have invited the broader team, and it appeared that the Spring team has already been thinking about similar approaches. So first of all, this kind of idea is not at all new in Spring Framework. There has been the remoting package that is now being removed because of outdated protocols. So these were different, old, and maybe outdated protocols, but the idea was the same. The mechanism was the same. You had an interface, you had a proxy factory, then a proxy that creates a client underneath, and there was this concept of symmetry. So the same interface could be used on server and client side. So this idea existed, and some implementations existed. It was just not very useful anymore because the protocols it employed were becoming outdated. And so, as we brought the idea to provide these integrations, we have realized that we could collaborate and create something new. And in fact, it appeared that Spring Framework 6 already had plans to create RSocket interface client on their own. Also, there was actually an issue that existed since 2014 to create HTTP interface client within Spring Framework. And it was deferred for, wait for it, Spring Cloud OpenFeign. So why would we create something in Spring if we have this fantastic Spring Cloud integration and people are happy and it works? And it did work until we had to be able to support the non-blocking communication. So as a team, we realized that this is an opportunity to revisit how we are approaching these issues. And that actually the underlying mechanisms are not specific to Spring Cloud. And in fact, if you see the Spring Cloud Square integration, it uses web client and web client filters underneath to provide the integrations. So the cloud features are just put on top. And some issues can only really be addressed best at the core, so within the Spring Framework. Because in order to make it in such a way that we will not have all these issues that we had before, we need to rethink the programming model and consider what we need and what not. And then take decisions about what annotations make sense for us to provide and which not, instead of just copy-pasting it. For example, as we had with request mapping. So we have decided to explore this within Spring Framework 6 and started creating our own interface client. And let me take you a bit through the thought process that we had while working on it. So first, we started thinking about the request mapping. Do we still want to keep it there? And then we realized that actually there's a lot of semantics inherent in request mapping that we would not be able to support on client side. For example, you can use wildcards, you can use virtually any HTTP method, and it's full openness, while for the client you need concrete things. And yeah, you need to be able to define a single request. You can use templating, but you cannot use wildcards of any kind. And also, there were some annotations for parameters, for example, that were super server specific. So we didn't want to make it all available and have the users think, oh, maybe we support this request mapping, but only without this annotation and without that, and you cannot put the wildcard, but it's all the same. No, it would be very confusing. So yeah, we didn't want to allow something like this, that you can have any HTTP method or any URL path and map one-to-n requests. Also, when you think about the method parameters, so request mapping is not just the annotation attributes, but what is important are all these method parameters. And some of them, the ones which we have in green, make a lot of sense both on client and server side. And when we thought about this, we even looked at the Java docs, and we thought, for these annotations, we don't even have to modify a whole lot in the Java doc. It just works both sides fine. There were some things which were specific, like, for example, a request attribute. So you might think that this is more server-side. However, we also use a request attribute in web client to provide hints for Spring security on which authentication method to use. And then, other than this subset, which works both sides, there were obviously some that would only make sense on the server side. So servlet request, servlet response, or model attribute would not make much sense on client side. Similarly, with the return values that we have. So some of them can be used for both clients and server, but some others, such as model or view or SSE emitter, would not make any sense for us on the client side. So we decided that instead of keeping request mapping also on the client side, we would introduce a new annotation called HTTP exchange. And we would use only a subset of parameter annotations that we would support on this side. So HTTP exchange will have the following attributes: URL, method, content type, and accept. And by the way, this all that I'm going to be showing here is already available in Spring 6 milestones. So you can go, give it a try, and let us know what you think, and create issues if you think something should be changed, or contribute pull requests. So this is all available. And if you see this in request mapping, we had path, we also had method, and then we had produces and consumes, which are kind of reversed here. And then also, we would reuse the method parameter annotations, but only the ones that make sense for us when we are using HTTP exchange. So the ones that we do provide right now, we have URI, that you can use the annotated parameter, but you could also override it by passing this through attribute. And we also provide HTTP method that you can define, but again, dynamically, you can override it through the parameters that you are passing. We provide request headers where you can pass strings, but you can also pass maps, for example. Same with path variables. You can have objects, but you can also have maps. And when it comes to request body, you can have objects, but you can also have reactive types, so mono or flags will work. For request param, when we have a form encoded, we will create a body out of it, and otherwise we will just add segments to our URI. We also provide cookie value, and there is also a plan to support multi-part for now. And similarly with return values, also a subset of the return values that we can expect for request mapping, we will be supporting for HTTP exchange. So as you see in this call, so this is actually exactly our HTTP exchange, and here we are using a post exchange created on top of HTTP exchange. So this is pretty self-explanatory. But this is the way that this Spring interface client already looks like, and you can already give it a try. As you can see here, we are creating, again, a simple post and just passing a body. And in this scenario, we are using blocking communication. So the nice thing here is that we will support both blocking and non-blocking mode, because just only if you change the signature, you can be returning mono, and we will take care of it underneath. So with the current implementation that is available, we are always using web client. But for the scenarios where you want a blocking call, we block it for you. You don't need to be taking care of it. So often people have an issue while starting with web client and with reactive communication that they don't know how to handle and where to handle blocking. Here it is done for you if you need this, but of course we also provide reactive and async support, and also we provide stream responses via flags. Also, we provide response entity, so you will be able to get status, headers, and body out of it. But maybe you only want HTTP headers, so you can get just that. Same, if you only want to execute something and are not caring about the response, you can use void. How are we instantiating such client? So for now, what we are offering and what we will see in the demo, you need to use an HTTP service proxy factory. You create the bean yourself for now, and but as you see, it's super easy. So we just need to pass a web client adapter as an argument, and there we are passing a web client. And the web client adapter is a class that's already being provided by us. And we are doing it in this way because maybe potentially you might want to work on your own adapter instead of using web client. So it allows you to do this, and maybe in future we will even do something like this if we get requests. And then your proxy factory is created. And once it is created, you just call create client and pass the class where you have this annotated interface. So the verification service class is the interface I have with all the HTTP exchange annotations. And you get your client. We hope that in future we will be able to provide easier auto-configuration and for Spring Boot to already declare this and make it available as a bin, so the user does not have to do this. And we are also planning to provide this kind of interface client for RSocket within Spring Framework 6, Milestone 5. So for Milestone 4, we already have HTTP, and with Milestone 5, we want to be providing RSocket. This probably will differ underneath when it comes to how it is built under the hood, but we think also it's going to be an interesting exercise in comparing the two models, and it might allow us to see what we are lacking in any one of them. So let's see that in use. So this was our OpenFeign client, and now we are going to be using the new one. So as you have seen in the slides, it is just a very simple bean annotation that we are going to be using here. And if you are thinking, what happens to the Spring Cloud integrations? Spring Cloud provides integrations already on web client level. So we have the load balancing integration for web client. We have the tracing integration for web client. So as we are going to be using web client underneath, we will be able to leverage this. And then we create our client, and like this, we get the verification service bean. So let's see where this is being used. It is being used exactly same as in the previous scenario, just to show you how easy it is to migrate if you were using OpenFeign or any other solution. And let's see the client itself. Yeah, so this is it. Obviously, as I've said, we provide the get exchange and all the other annotations that were on slides, so you can already try using it. And we have this one running under 9085. So let's try doing a bit of requests. OK, as you see, it is already done. And let's see the logs. Yeah, so as you see, we actually have the exchange function, so the web client creating and sending a post, and we are getting some kind of response, and then we are also able to get a status and also decode it. So let's take a look on how this works underneath, because as we've seen from the user perspective, it is super easy to use. You just create this one bin, and it pretty much works. So let's see what it is that is actually happening underneath. So this is our service proxy factory. And in order to create this client, we will need to extract out of this interface, we need to translate it into certain metadata that we can use for our HTTP calls underneath. So we have here, obviously, this is just something that I'm sharing with you because so you can have an opinion on how this is built and maybe also participate and create pull requests and so on, but the user doesn't really have to handle this. So what you get is the HTTP service method that will have the method, parameters, some values, and last but not least, it will have the argument resolvers. So this is actually what is responsible for translating our annotated elements into actual elements for the HTTP client calls. And as you see, we have added quite a lot of them at this point, so we can resolve all these elements. We have the URL. For example, we also had the path variable. So again, the annotation is same as the one that we were using on server side, but now we are going, as you can see, it's the same annotation, but now we are going to use it on the client side. And yeah, we have another bunch of resolvers. And whenever we want to be able to support another annotation or something else with the body or with the headers, this is where the modifications will be happening. And yes, so this is what we have so far when it comes to the interface clients. We think they're already usable, so you can take a look at the milestones, and please do, and please let us know, because you might be able to find some possible issues. And yeah, we would like to invite you to start using it and let us know what you think, and please look forward also to the RSocket client. And I think now we will have time for questions.
Okay, time for questions. So please raise your hand. And yeah, if you are online, I'm checking your question as well. So please do it.
You can also let us your observations, what you think, your experiences with previous using interface clients, why you like them, why you don't like them. Yeah.
Okay.
Feel free to
Who
let us
is
know.
using Spring in production? Okay.
Who is using Spring Cloud OpenFeign or Spring Cloud Square? Okay, and who would like to use the new interface client based on what you've seen?
Okay, 1 second.
1 second, let's wait for the mic because I can't hear too much.
So, okay. We use Spring in a project, and one of the problems that we have with the web clients is handling the retries. So we have a lot of specific logic on the retries. How in the OpenFeign or in the Square can we handle retries since it's only annotations?
Okay, so, well, if you are using load balancing for these calls,
Yes.
so actually load balancer handles retries for you. So both if you're using it with REST template and with Feign, this is actually already implemented, you need to add Spring retry. And if you are using web clients, we are using the reactive retries logic, and it's also implemented. You just need to turn a flag on in the documentation. You will find exactly which flag. So you can do it, and you can also already configure some things when it comes to how many times to retry, how many times to retry on the same machine, on different machine, on which kind of exceptions or status codes to retry. So this is already available.
But with Spring retry or the
Spring retry if you're using OpenFeign or REST template, and for web client, reactive retries, and you don't actually need to add additional dependency. You just need to turn on a flag and add some configuration.
Okay, thank you.
Okay. Hands up for questions. Okay.
Hi.
Hi.
Thank you for the talk.
Thanks.
Actually, I have a couple of questions. One is, how is the interceptors interface with this client? And another is, how does it work for automatic instrumentation for end-to-end tracing?
Okay, so when it comes to the tracing, the current implementation we have with a web client underneath. So web client is instrumented. So since this is going to be used with Spring 6, because it's not available before, you don't even need to add Spring Cloud Sleuth Starter, because now all that was happening before with Sleuth has been moved over to Spring Observability. So actually Spring Boot will be setting it up for web client. And when it comes to the other question, we are actually going to be using this service method. So let's go back to where we were creating this. So I can show you. And as you see, this is where we are creating the proxy. And we have this HTTP service method interceptor that will take all the data. So the parameters, the method, the resolvers that I've been showing, this is exactly this class.
Okay, thank you.
Thank you.
Okay. Who else has question, please? Hands up. Oh, that's amazing. So next guy must be another way, so you were able to keep the volunteer working.
How do you plan to add authentication to these kind of automagic endpoints that are generated? How can I define that an endpoint needs to be authenticated and the other doesn't need?
Yeah, that should probably already be configured at web client level.
Yeah, but we can have, should we implement at least one web client per endpoint or per set of endpoints? For instance, we could have an API of users that for a get it doesn't need authentication, and for a post it does. How can we define that? We need to split that into multiple implementations in order to use multiple web clients, right?
Okay, yeah. So a lot of things you would set up obviously on the server side, and then what you would do on the client side, you would be passing specific data, so headers or cookies. So obviously you need to pass them wherever you need them. So this is exactly same as if you were using any other client. It is just only a layer on top of it to make it more readable and easier to call. But ultimately, whatever you will need to configure for the client underneath will have to work in the same way.
Okay, thank you.
Okay. Okay, we have more 12 minutes to questions, so don't be afraid to ask questions. And again, if you are online, please write down your question. I will be able to track your question. Okay, give once. Give twice. So thank you. So it was an amazing presentation.
Please give it a try and let us know what you think. This is very important that you do this during milestones because we can still change things. So please help us. Thank you.